In the previous video, we talked about the moon being in synchronous rotation and that being a consequence of the tidal forces of the Earth on the moon. Now, tidal forces are really the force of gravity that causes this stretching and drag. The details are very complicated to get into, but the basic idea is pretty simple, that gravity stretches an object because it's stronger on one side than the other, and as that object is rotating, there is a resulting drag on it, which causes it to slow down a little bit. Well, the moon has a similar effect on the Earth, but the Earth has water on it, and so the effect is actually a little bit more noticeable when it comes to the tidal forces of the moon on the Earth, and so that's what we're going to get into in this video. Okay, so this is a diagram of the Earth essentially as a big ball of water. Right, so we're thinking about the water of the Earth. And this is the direction of the moon. Okay, so the net effect is that the water of the Earth bulges out along the direction to the moon because of gravity. Now, if you want to see why that is, this diagram here, the arrows are indicating, easy for me to say, the strength of gravity at that particular location. So gravity decreases with distance, and so the strongest gravity is here on this side, the closest to the moon. It's weaker over here. It's a little stronger over here. It's stronger over here. But the further you get from the moon, the weaker gravity is. And that means there's like a differential in the strength of gravity from one side to the other. And that difference in force leads to a stretching effect. The Earth gets deformed a little bit. Now, this stretching force is going to have more of an effect on a liquid like water than it does on the land. And so it's really the liquid of the Earth that gets deformed by the moon. And the land has a much, much smaller reaction to this tidal force from the moon. And it's called a tidal bulge. The liquid of the Earth, the water, forms a tidal bulge. There's a little bit more water piled up near the center line to the moon than there is away from that center line. So more water piles up here and here because of this stretching force. Now, as the water is oriented in this tidal bulge, the Earth is spinning around. So what happens is that the Earth rotates through the tidal bulge. The tidal bulge is directed only by where the moon is located, but the Earth is spinning around faster than the moon is moving around the Earth. So the Earth is rotating through the tidal bulge. Now, let's look at the second picture at the bottom. When the tidal bulge is oriented this way, here is high tide, here is a high tide, here is a low tide, here is a low tide. So every day, the Earth rotates through this tidal bulge, and the locations on the Earth go through low tide, high tide, low tide, high tide. So every day, there's going to be 2 low tides and 2 high tides as the Earth rotates through this tidal bulge. So it's not so much that the ocean currents are responsible for the tides, which is probably the default thinking, that there are currents on the Earth that are pushing the water this way and that way. It's more that the moon is stretching the water of the Earth, and the Earth is rotating underneath it, pulling us through high and low tides over the course of a day. The sun also has an effect on the tides, but it's just a lesser degree. And you might think, well, how can that be? The sun is so much bigger, but it's also so much farther away. So the sun is going to have tidal forces on everything around it, but its distance is so much greater that those tidal forces are weaker. The moon is close enough to have a big effect on the Earth's tides. The sun has a smaller effect on the Earth's tides. Now, because they're not always in alignment, those effects are pretty complex, right? The moon might be stretching the water of the earth in one way, and the sun is trying to stretch it in a slightly different way. And so the tides are not exactly the same every day. It depends on how the sun and moon are aligned. When you get the situation where the sun, moon, and earth are all in a line, so you're either at new moon phase or full moon phase, then you have the biggest the tides can possibly be, because the moon wants to stretch the earth's water this way and the sun wants to stretch the earth's water this way. So they agree and they're working together. And so you get the biggest tides possible. We call those spring tides. And if they're working opposite to one another, like they are in the second picture, the moon's either at first or third quarter. Well, the moon wants to stretch the earth's water this way. The sun wants to stretch the earth's water this way. And so they're working against one another. And the tides are going to be smaller than normal, the smallest they can be. Now, high tide is still going to be determined by wherever the moon is, because the moon's effect dominates. But the high tide won't be as high as it used to be, and the low tide, the difference between these won't be as extreme. And we call those neap tides, because the sun is pulling the water about this way. So the low won't be as low as it used to be, and the high won't be as high as it used to be. So we have spring tides and neap tides, and those are going to occur at the first and third quarter and the new and full moon phases. So every month we're going to have 2 spring tides and 2 neap tides, and every day we're going to have 2 low tides and 2 high tides. And that's essentially it. That's the way tidal forces affect the earth primarily is to cause the ocean water to stretch out and the earth to rotate through it. And obviously this has a lot of importance for our industries that involve the ocean. But there's one location on the earth where this is really an extreme effect. Actually, there's a lot of locations where it's really extreme effect, but there's one location where it's the most extreme effect. And so I want to show you that in the next slide. Before moving on, I did put a link here. So if you're having trouble visualizing what's happening with the tides, and you open this link, I think I have it up here, you should see this, and you can run this, and it will show you the moon going around the earth. The tides are following where the moon is. So high tide is always in line with the moon, but the earth is rotating through it. So every day the earth's going through high and low tides. The sun is also working in this picture. So if we include the sun, then what you'll see is that it has a small effect. And so the height of the high tides is getting smaller as the sun is working against the moon. So now it's not getting as high as it used to be. We went through neap tide right there. And then eventually we'll get back to high tide. The high tide's getting bigger and bigger because the moon and sun are now working together. Now we're at high tide. There's one more effect on here that's modeled that I didn't mention, but that's that the earth actually drags the tides with it a little bit. So there's one more degree of complexity here. Because the earth is spinning and the liquid is attached to the earth, it drags the water with it. So I've been saying that the high tide is in line with the moon. Well, it's actually leading the moon just by a little bit. So if I include that effect of Earth's rotation, the high tide is just a little bit in front. And that's because the moon is pulling the water out that way, but then the Earth is dragging it with it as it rotates around. Okay, and so this is essentially what's happening with the tides on the Earth. So if you're having trouble visualizing, I think this is a helpful little tool. Okay, back to this. But then I'll finish with the highest tides occur in this location, the Bay of Fundy in Canada. I don't know if any of you have ever been up there, but the tides there are so extreme that all of the water in this bay just totally drains out every day. It has to do with the way that the shape of the bay is oriented relative to the flow of water. And so I put a link to a video here where you can watch the tides go in and out. and they give you a little bit more information about like how much water is pouring in and out of this bay. But essentially what happens is at low tide, the bay looks like this, and at high tide, the bay looks like this. And it's the most dramatic tides that we have on the Earth.